All right, gang, the purpose of this video is to work one of the demo videos. So we should know what to do by now. So go to STAT1800. Again, it's going to look a little different because I'm building the course. We call that enhancement, so whatever. Go to assignment, and you will find demo number 1, lesson number 3. So I think there are 6 problems here. Again, I've already done these, completed these problems. The reason is it just streamlines the video and makes it shorter. So let's dive into the first question. So the first question, given a normal distribution with mean 50, standard deviation 4, you select a sample of 100, complete parts A through D. So the first is, what is the probability that X bar? So this means that we are residing in the sampling distribution problems where our standard deviation shifts to the standard error. And remember, the standard error is nothing more than the standard deviation divided by the square root of n. That's been taught in the previous couple of videos. So hopefully that's something that you're pretty familiar with. But nevertheless, we go to normal. Let me make this larger where you can see it, or maybe I can see it. All right, so mean 50. Let's insert this. Standard deviation is 4 divided by the square root of the sample size, which is 100. And I'll tell you, it's so easy to get sloppy here and just put that standard deviation of 4 in there and not divide by the square root of the sample size. And if you want to wake up tomorrow and get all these problems wrong, then do that. It's just not going to work. So that's just something you have to do. So we need X less than 49. So you can see I get 0.0063 as I've entered. What is the probability? 49, between 49 and 50.5. I'm going to go up here and select between. So I want between 49 and 50.5. So you can see I get 0.8881, which I've entered there. What's the probability that X bar is above 50.8? So I want to go back to standard. I want to go above. And if it was my grade, when I do that, I would make sure that the mean and the standard deviation, the standard error in this case, are still the same. So they are, so I would hit compute, and you can see I get 0.0228 as I have entered. So part D is a little different. This says there's a 30% chance that a particular mean is above what value. So what I need to do here is select above, but I need my answer, so to speak, to be the 30%. So what I want is I want to find the value that has 30% of the distribution above it. So I'm not actually calculating a probability like I did A, B, C, A, B, and C. I'm finding the value that separates the top 30% with the lower 70%. So you can see I get 50.21, which I have entered there. Next question. I like this question because it kind of brings up some things that we've learned previously. So a report announced that the median price of homes in 1 year was 211,000, and the mean was 272,600. Standard deviation 90,000. Now, when I see that, I see that there's a huge discrepancy between the mean and the median. And what did we learn a couple of lessons ago? When the mean is quite a bit larger than the median, what kind of distribution do we have? Well, we have a right-tailed distribution or a positively skewed distribution. So part A says if we select random samples of n equal 2, what's the shape of the distribution? Well, it's going to remain being skewed to the right because we haven't yet met that threshold of a sample size of 30 or larger, as again I taught in a previous instructional video. So we're not there yet. So the sampling distribution will be the same as the the probability distribution of house prices taken one at a time. Now, if we select samples of n equal 100, then we go above that threshold of 30, and then we can see that the sampling distribution will be approximately normal, allowing us over here to the right to use the normal calculator. So if we select a random sample, what is the probability? The sample mean will be less than 300,000. So I need to come in and put the mean, which is 272,600. I need to put the standard deviation, which is 90,000, divided by the square root of the number of houses, which in this case is 100. And I need less than 300,000. So I get 0.998, which you can see I entered right there. Probability of the sample mean is between two numbers, so I want to go up here and grab the between. And I tell you folks out there that are committed to using those archaic standard normal probability distribution tables, I don't get it. And especially don't get it when we get to this point. So, but you keep doing what you're doing, and I'll keep doing what I'm doing and doing much, much, much easier and quicker. So 0.3107. All right, next question. In a random sample of 72 people, 18 are classified as successful. Determine the sample proportion P of successful people. Uh, what I would do there is just take 18 divided by 72. There's really not much that can be done there. Uh, the next thing we want is if the population proportion, easy for you to say, is 0.70, determine the standard error. So what I would do there is I would just, I wish I had something I could write on. Um, let me, well, I really don't. So anyway, what I would do there is I would just take the square root and I would take 0.70 times 1 minus 0.70, which I can do in my head and you probably can do. So I'm just going to type in 0.30. And I'm going to divide that by the total sample size, which is 72. Now, make sure that all three numbers, the 0.70 times the 0.30 divided by 72, make sure all of that is under the square root in your calculator. If it's not, you're going to get the wrong answer. I get the answer 0.0540, which I have typed in, and of course it's correct. All right, apparently we have a candy company, 22% are orange. Find the approximate probability that a random sample of 500 will contain 25% or more orange candies. So kind of same song and dance here. We put in the mean, which is 0.22, put in the square root of 0.22 times 1 minus 0.22. I can do that in my head. If you can't, grab your calculator. Nothing wrong with it. Uh, and then we have a sample size of 500, so then close that. Now, the next thing I want to do is I want to go to standard because I'm doing calculation greater than. And again, I would just double check that these values, the 0.22 and the standard deviation didn't change. They shouldn't when you go between and standard, but just double check. So I get 0.053 as I have entered. Wow, that was pretty easy. That was quick. Uh, According to a law association, 62% of people who take the bar pass the exam. Okay, well, that's comforting. Uh, find the approximate probability that at least 70%, so that means 70% or higher, are taking the exam will pass. All right, let's do it. So they claim that 62%. So I need the square root of 0.62 times 1 minus 0.62. Again, I could do that in my head and see that's 0.38. If I needed to use my calculator, I'd grab my calculator. I would just go 1 minus 0.62. Nothing wrong with that. Uh, we all have different gifts. You should see me draw. It's horrible, absolutely horrible. So P greater than 0.70 or 0.07, 0.7. I can do stats, I just can't see. So the answer would be 0.05. I think the hardest thing about that is actually rounding because you have 0.0496. But when you round to the third place, that fourth digit requires you to round the 9 up to 0 and the 5 up and 4 up to 5. So that may be the hardest part of the question. All right, final question, multiple parts. According to a survey, 75% of teens way back in 2009 in a certain country used social network or not used social networks. Random sample of 150 teenagers was selected. All right, so the standard error, we're going to take the square root of the p, which is 0.75, times 1 minus the p, which is 1 minus 0.75, which I think we can all see is 0.25. And I want to divide by the sample size, which is 150. So I get 0.0354. And again, I can't preach this loud enough. All three numbers have to go under the square root. I see so many people that will do like the square root of 0.75 times 0.25, and then they'll divide all that by 150. They don't put the 150 under the square root. And, that's it's not going to work. All three numbers have to go under the square root. So what's the probability that less than 77%? So I need to put in the correct mean. Let's just, we have the standard deviation, so let's just use it, 0.0354. And we want less than 0.77. And you can see I get 0.7140 as I entered. Between 70 and 80%, let's go to the between function. You compute 0.8422. Now, what impact would changing the sample size to 200 have on the results in A, B, and C? Well, what would happen is our standard error would decrease because we would be dividing by 200 instead of 150, and let's just do that. So instead of dividing by 150, I'm going to divide by 200, and my standard error went from 0.035 down to 0.031. So the standard error reduced. So I know that the answer has to be either A or C, which in turn would what? Reduce the probabilities or increase the probabilities? Well, let's just check it out. If we change the standard error from 0.0 to 354 to 0.0306 and calculate for 70 to 80%, oops, got one too many decimal in there. Our probability went from 0.8422, and I'm looking at question C, it increased to 0.8977, right? So therefore, the probabilities of the proportion would be closer to the population proportion, making them increase. So this is the key word right here, increase. All right, gang, that's it. 6 out of 6, right? I hope this helped, and I hope this leads to you doing exceptionally well on your assignment, which will include a lot of questions just like this. All right, take care.